I basically grew up in forest, and I lived in a small place, and I spent all of my childhood playing in the forest. Forests are an amazing example of the circular ecosystem. Everything in the forest is going to be biodegradable, everything circulates, and by looking at that, we can draw a lot of inspiration and take it to our research.
To combat climate change, there is an urgent need for new, renewable materials. Materials chemist Mika Sipponen explores one of nature's most abundant and versatile components, lignin, a key part of wood.
About 25% of this tree is made of lignin. It's on the surface of the tree in the bark, where it gives the protection for different external factors like microbes, rain and sunlight. And inside of the tree, the lignin gives the enormous strength for the tree to grow up to the sky, 20 meters or more, and make the water transport possible from the roots to the very top of the tree. So it is a multifunctional material.
When making paper, lignin is extracted as a byproduct. Yet, despite its potential, only a small fraction of lignin is reused. The overwhelming majority, 98%, is burned for energy. Mika Sipponen believes this underused material holds great promise. With the right methods, lignin could replace fossil-based materials. However, its complex molecular structure makes it challenging to process.
Well, it's not easy. It's not like a baking powder that you can bake any type of cakes. So one needs to control that chemistry. But in principle, you can make all kinds of forms like filaments, you can make three-dimensional objects like foams, and you can make so-called adhesives that are used to glue together, for example, wooden products. So this is our starting material. This is lignin powder, and we can use it in multiple ways.
Using green chemistry principles, which includes avoiding toxic or unsustainable substances, Mika Sipponen and his team are developing new methods to process lignin into versatile materials.
So now I'm going to show how one can make nanoparticles from lignin in a very simple way. The first step is to take the lignin powder and make it into a solution. And we use normally a solvent like ethanol or acetone. In the second stage, we simply take water and mix it with the lignin solution to form the particles. I can show this to you. So what we have here is now lignin nanoparticle dispersion.
The lignin has formed tiny spheres, and they can serve as building blocks for other materials, like this gel, which could form the basis for an adhesive or even a hair conditioner. The researchers have also developed a lignin-based foam as a sustainable alternative to fossil-based insulation. It must meet critical properties such as fire retardancy, which is tested here in the lab.
As we can see, the cotton burns and our lignin foams burn very slowly.
In its natural form, lignin is brittle. However, Mika Sipponen and his team have found ways to make it flexible.
Lignin is really quite challenging to make it like elastic because it has a brittle structure, you see. But here we make lignin that like can be bended or even stretched, and it's returned to its original state without any breakage.
Mika Sipponen is determined to bring his research out of the lab and into society. To scale up the results, he has started a spin-off company. One of the first products could be a wood adhesive.
So this skateboard is a nice example of a wooden product where we have thin slices of wood glued together with an adhesive that is currently made of fossil-based chemicals. And here we want to use our lignin-based adhesive as a more sustainable alternative.
Inspired by nature, The goal is to make adhesives and other lignin-based materials reusable and circular.
One day this tree will fall down and die, but it will be biodegradable and part of the circular system, the ecosystem. Same way, we try to make our materials circular and sustainable so that they will satisfy the needs of our society.